Hi, I'm Victor-Hayashi from the University of São Paulo, and together with my colleagues Felipe, Almeida, and Andrea Komo, I will present our work LabBitcoin, FPGA IoT testbed for Bitcoin experiment with energy consumption. The blockchain technology has been gaining a lot of academic and industry interest. Its main application, its most popular, is the Bitcoin, that is the peer-to-peer cash system that enables these financial transactions peer-to-peer. So for example, a Bitcoin miner expends computing power and energy for the proof of work consensus algorithm in exchange for some amount of Bitcoins. Our motivation is the high energy consumption of the Bitcoin network, ranging from 60 to 125 terawatts hour per year, which motivated some research regarding holistic analysis to investigate if this is really this high or not. And the minimization of energy losses is also another work that we found in the literature. And we could find the related work or the state of the art in Brazil. We could find the proposal of the usage of the field programmable gate array, the FPGA, as a Bitcoin miner. This work was from 2012. And another work from last year, 2020, that it was about a performance and security analysis of the blockchain technology. But it didn't have the energy consumption aspect. And actually, both these related work were based or on specifications or based on simulations, not on real test beds that enabled some experiments with real hardware devices. Our objective is to provide practical activities related to the Bitcoin mining to motivate developers, students, and enthusiasts to consider this emerging aspect, this energy consumption, in their FPGA miner design. We believe that by allowing access to a remote lab based on IoT, the Internet of Things technologies, could enable these activities in real time, and also additionally foster integration with web and mobile interfaces. So we could open a wide range of applications and new ways to interact with these blockchain and Bitcoin technologies. So here we have the LabBitcoin architecture. We have the computer that the student or developer uses to create the design. It must compile and then deploy it in a real FPGA board that when it is mining by the Bitcoin miner design, it has an energy consumption that is monitored by a smart meter. This IoT device is connected to a public subscriber protocol, that is the MQTT, that is integrated with a MQTT broker, Mosquito, that is deployed in a cloud computing environment. It is also integrated with a web dashboard that is communicating by a WebSockets connection with a web dashboard that we developed. And we could also integrate our infrastructure with open source MQTT mobile application that is compatible for the Android devices. So we have these both interfaces that we could integrate our solution. Here we have the mobile user interface on the left. So we have the topic for the energy consumption and also the topic for the commands. So we could provide commands such as power on the FPGA board, power off the FPGA board, the miner, and also halt the miner, for example, or reset it. Here on the right, you have the web dashboard that we built. So we have the total power consumption and the power consumption by each lab bench, by each of these FPGAs. And we could see the total power consumption in real time of this cluster of Bitcoin miners. We could deploy our solution in 4 lab benches in the University of São Paulo. So here we have and right the smart meter built with IoT development board, the current sensor and the relay and other electronic components, and also the FPGA itself where we will deploy the Bitcoin miner. Here we have a little demonstration by my colleague Felipe. So let's take a look.
So now I'm gonna demonstrate our dashboard. I'm using AnyDesk software to remote connect in one of our benches in the laboratory, the A8 bench. I have our dashboard here showing 4 different benches, but we're only gonna use 2 of them, this one and this one, in this demonstration. And here I have BlueStacks emulating an Android device with the open source and free MQTT dashboard. Here I have some buttons which I can use to control our FPGA boards with different signals. As you can see here, I'm measuring the A8 and A7 remote bench energy consumptions. The same value is also shown here in our dashboard, and here in the top left corner we are showing the total energy consumption. Well, both of the FPGA boards are mining at the moment. We can see here some high energy consumption. I can, for example, halt one of them, so I'm gonna halt the A8 at the moment. The LEDs are gonna stop glowing. When I halt one of them, the energy consumption lower. Now we are near the 3 watts, and this one is almost 4 watts. When I stop the halting state, I need to give some reset in the mining so it can return mining. Now the bench is continuing the mining process. Our dashboard at the moment it's giving fully support to 4 different remote benches, but it can be easily extended to use more benches, more FPGA boards, more devices. It have a good possibility to future works here. I'm gonna just give a halt state in the A7 too. Now the A7 is halted. You can't see here because I'm just connected to the A8 board, but it's halted. So that's it.
So we have this table where we could see the end gauge for the benchmark of 2.5 watts, and for the 50 megahertz and for the overclock, you could see also the power consumption. So this is one example of these experimental results that you could obtain with our solution. To the best of the author's knowledge, this is one of the first works that combine a remote lab with IoT technology to monitor the energy consumption of this Bitcoin miner. And future work may address a public access to this proof of concept that we presented, and also a workshop with students to see if these practical activities foster creative applications using blockchain technologies. So this was the LabBitcoin work. Thank you very much for your attention.